I'm going to have a look at graphs now. There are basically two types of graphs that you'll have to learn. There's the linear graphs, which are straight line graphs, and non-linear, which are the curves. So I'm going to start off with the linear graphs. Now, there's some special graphs that you need to be very familiar with. X equals 1. It crosses the x-axis at 1 and looks like so. So if I had x equals 5, I would go across to 5 and draw a line straight through the x-axis at that value. Similarly for y equals minus 2. So you go up the y-axis to minus 2 and you draw the line straight through it. The next graph that's important to recognise is y equals x. This is the one that goes straight through the origin. So there's my origin there. Mark it with a 0. And it's a diagonal 1. Now, you can be asked to draw any type of linear graph, and they can be written in different ways. So like if this graph, if I was asked to draw this graph, what I would do is I would choose x to be 0, then cover it up and work out the y. So you can clearly see there, y is 5. Then what I would do is I would cover the y up, so that's putting it to be 0, and you can see x equals 5. I'm plotting that on. X is 0, y is 5, and x is 5, y is 0. When you draw a line, it's always a good idea to label it. So x plus y equals 5. I would just use the exact same method for this one here. So what I would do is I would choose x to be 0, so cover it up. So 4y equals 12, so y equals 3. And then I would choose y to be 0, so cover up the y. 3x equals 12, so x equals 4. So x is 0, y is 3, x is 4, y is 0. So just joining those up, and again I would label that line 3x plus 4y equals 12. For this one here, you can draw out the wee table of x values. So for that there, for this one here, I'm going to use a simpler way of saying it crosses at 5, and it's got a gradient of 2. So that means if I go across 1 square, I will go up 2 squares. So if I go across 1, I will go up to 7. And you just join that up, and that's that graph drawn there. Now you could use the same method for this one, as in it crosses at 1, and the gradient is minus a half. So that means you go across 1 and down a half, and then join the points up. But what I'll do this time is I'll illustrate how you do it choosing points. So you can pick a couple of x values, say x is 0, and work out the y. So 0 add 1. If x is 1, minus a half add 1 is a half. And if x is 2, minus a half times 2 is minus 1, add 1 is 0. So plotting that on, x is 0, and y is 1, x is 2, y is 0. So you get the same graph if you just do it by looking, or if you work out the points. So that graph is y equals minus a half x, add a 1. The next thing I want to look at here with straight line graphs is the coordinate geometry element. Now these equations must be learnt off. You must be very familiar with these. The equation of a line can be written in two ways. Either y equals mx plus c, or y minus y1 equals mx minus x1. x1, y1 is a point the line goes through. C is where it crosses the y-intercept, and in both cases m is a gradient. So it's a difference in y's over difference in x's. You also need to know the midpoint. The midpoint of a line is the average x's divided by 2 and the average y's. So you add up the x's divided by 2 and add up the y's divided by 2. The length of the line is the difference in the x's, and you square that. You work out the difference in the y's, and you square that. Add the two together and square root it. It's basically Pythagoras' theorem. And this is for T4 people only. Perpendicular gradient means minus 1 over the gradient. Now perpendicular means at right angles. So if you had a line like that and that gradient was 3, the perpendicular gradient meets it at right angles, and the gradient of that line would minus a third. Now I've got a couple of examples using coordinate geometry here. The midpoint of the line joining A and B is that. Find B. So my A point So that, my B point I don't know, we'll just call it xy. But I know the midpoint is 1, 3. Now, to find the midpoint, it's the average x's, so 5 add x divided by 2, and it's the average y's, not add y divided by 2. And you're told this answer is 1, 3. So if you look at your x's, so 5 add x divided by 2, the answer should be 1. Bring that 2 across and multiply, so 5 add x equals 2, so x equals 3. Do exactly the same for the y's, so not add y over 2 equals 3, so y equals 6. So your B point is your x and your y. Number 2, find the value of q if the line joining the points 2pq and 4 minus 6 is parallel to the x-axis. Now, parallel, anything to do with that is your gradient. The x-axis is a completely flat line. So what you want is you want the gradient to be equal to 0. Now, to find the gradient of 2 points, it's the difference in the y's. So q minus 6 over the difference in the x's. 2p minus 4. Now, if you notice, I started off with this q and then subtracted this minus 6, so I must start off with this 2p and subtract that 4. Whatever coordinate you start with for your y's, you must start with for your x's. You know that equals 0. Tidy this up a wee bit. Q plus 6, the top line. The bottom line is over there to be multiplying. Anything multiplied by 0 disappears. So q adds 6 equals 0. So q is minus 6. The next question I have. The lines y equals 2x plus 6. Now that I'm reading that, I'm saying to myself the gradient is 2 and the y-intercept is 6. And this line y equals ax minus 2. So the gradient is a and the y-intercept is minus 2. They're perpendicular. So that means the gradient of 1 is minus 1 over the other gradient. So the gradient of this line here is minus 1 over this gradient. So you can read that straight off as a is minus a half. Next example. The lines y equals kx plus 6 and ky equals 4x minus 2 are parallel. Now the first problem I have with that line is I don't have y equals. So I'm going to rewrite this one as y equals 4x over k minus 2 over k. There should be an x in there. And this one here is just y equals kx plus 6. If they're parallel, they've got the same gradient. If you remember, the gradient's number in front of the x's. So parallel. The gradient of this one is k. The gradient of this one is 4 over k. They have to equal if they are parallel. Bring this k across here so it becomes multiplying. So k equals plus or minus 2. Remember, when you bring the root over, you have positive or negative answers. Number 5. Find the equation of a line. So I'm thinking y equals mx plus c, or y minus y1 equals mx minus x1. I'm not sure which one to use yet, so we'll just keep reading on. The gradient's minus a half. That fits nicely into both. So minus a half. And it passes through the origin. So that means the y-intercept is 0. So I can just put 0 in there for your c. Which means the coordinate it goes through is 0, 0. Tidying this up, y equals minus a half x, and tidying this up, minus a half x. You get the same answer no matter what. Number 6, find the equation of a line with gradient a half. So we'll write this up over here. Now either method is fine, y equals mx plus c, or y minus y1 equals mx minus x1. You're told the gradient is a half, so put a half in for your x value. We'll come back for our c in a second. So we're just putting our gradient in. Go and read more of the question. You're told it passes through 4 minus 3. So I'm going to use this equation here because it passes through 4 minus 3. So y is minus 3. Oops, it should be a half. X was 4. Now, this one here, if I just finish this off, so you have a half x minus 2, bringing that over half x minus 5. For this one here, it's just not as simple. You're not told the C value. You're told the line goes through 4 minus 3. So what I'm going to have to do is, I'm going to have to work out my C value. So go over to the side to do that. Y is minus 3. Half times x is 4, plus c. So minus 3 equals 2 plus c. Bring that over and subtract. C is minus 5. So your answer is y equals a half x minus 5. Same answer by either equation. It doesn't really matter which one you use. Number 7. Now, for number 7, where you're given 2 points like this, and neither of them are the y-intercept, so you're not given what happens when x is 0, I would be inclined just to use the harder formula, this one here. Now, your x1 and y1 can be either point. It doesn't matter. I'll go for the positive one. So y minus the y coordinate equals mx minus the x coordinate. Now, to work out m, it's the difference in y's, so I'll go 5, take away 2, over the difference in x's, minus 3, take away 6. So that's 3 over minus 9 minus a third. So popping that in, y minus 2 equals minus a third x minus 6. Multiplying out those brackets, minus a third x plus 2. And tidying that up, minus a third x plus 4. And the last one I have here is for T4 only. Find the equation. So I see 2 points here. Y minus y1 equals mx minus x1. Perpendicular means my gradient is going to be minus 1 over. Okay? Bisector means I'm splitting this line in half. So you're finding the midpoint. So bisector means you're finding the midpoint. To find the midpoint, you add the x's together and divide by 2. Minus 1 add 5 is 4, divided by 2. 4 add 12 is 16, divided by 2. So you've got the midpoint worked out. That's the point your line goes through, because it's a perpendicular bisector. So y minus your y coordinate is minus 1 over m, x minus your x coordinate. Now I've got to work out my m. Your m is the difference in the y's, so 4 minus 12 over the difference in the x's, minus 1 take away 5. So it's minus 8 over minus 6, which breaks down into 4 over 3. Now putting that over here, y minus 8 is minus 1 over 4 over 3. If you ever have 1 over a fraction, you turn it upside down. So it's minus 3 quarters, x minus 2. Multiply that through, minus 3 quarters x plus 6 over 4, which is 3 over 2. Bring that 8 over and add it on. Minus 3 over 4, that's 1.5, plus 8 is 9.5. So you write it's 9.5, or you could write that as 19 over 2.